Some technical issues with my laptop, but welcome again to the second lecture of this afternoon. Today, this time we're joined by Michelle Govender. And Michelle Govender is a leader in cybersecurity dedicated to building resilient and secure digital businesses. With a background in engineering and a passion for organizational design, she has spent her career driving cybersecurity strategies that safeguard critical infrastructure. Her mission is to empower businesses to navigate the digital future securely and confidently. Her experience spans cybersecurity strategy for power utilities, culture transformation, risk management, and cyber resilience. As a certified professional engineer and certified information security manager, Michelle contributes to shaping cybersecurity governance at national and international levels. Committed to knowledge sharing, she actively contributes to CIGRE's global initiatives and the South African Institute of Electrical Engineers, helping practitioners stay ahead of cybersecurity challenges. Michelle is an advocate for a security-first culture and security by design, inspiring organizations to embrace digital security as a digital transformation enabler. And with that being said, I'm going to hand it over to Michelle now to start her presentation. Thank you so much for being here.
Thank you so much for having me, and what a privilege and honor to meet all of you today on this late evening. Thank you so much for making time, and I'm hoping that I could share some of my experience and that this will make an impact to you and your learning journey. So today we're going to talk about the OT cyber threat landscape in energy. And we're going to look at it through the lens of managing risk from a governance perspective. Just to give you by way of introduction, cybersecurity and governance, specifically in energy systems, is not just a technical necessity. It's a national security matter. With the rise of cyber threats targeting energy grids, nuclear facilities, and renewable energy infrastructure, organizations are waking up to the fact that by adopting strong governance frameworks and practices, they can then ensure reliability, safety, and compliance of their energy system, thereby building resilience as a strategy for the business. Hi, everyone. I'm Michelle, and it's a pleasure to speak to you today on this topic of managing cyber risk in the energy landscape through the lens of governance. So without further ado, let's just dive straight in. Okay, so a blast from the past, just to share with you a little bit about my journey and to also hopefully inspire you to know that wherever you are right now in your journey and career, that there's always opportunity for you to actually pivot into the cybersecurity field and make a meaningful impact. When I started my professional career, I didn't imagine that I would be doing this. My interest of study and practice. I started off my journey at the University of KwaZulu-Natal in KZN, where in my first year, I registered to complete a computer engineering degree. One day, while tagging along with a third-year student, I discovered the Synchronous Machines Lab, a fancy name for a generator, and discovered that I actually wanted to work in the world of electrical engineering. And my interest in the energy system as a whole began. Who would have thought these many years later that these worlds would collide and that we'd be working on securing these systems and infrastructure against cyber threat? I then went on to work in the field, looking at substation automation and design, where I spent most of my professional young life. And it was then through that experience that I registered at the Engineering Council of South Africa, which I think was quite a pivotal moment for my professional journey, because I was actually one of the first people to register for a heavy current engineering qualification registration using cybersecurity program experience. So I was very grateful for that opportunity, but also it opened my mind to the changes that we would need to make as a fraternity to be able to equip young engineers to deal with these issues of the future. Cyber risk management requires that we understand the nature of the systems, which is where I use my engineering knowledge, that we secure, and requires collaboration between plant engineering as well as maintenance teams and cybersecurity teams, which are often teams that are formed in the information science part of an organization, or commonly known as the IT areas of the business. Some of these facilities operated only by machines in the energy space with little to no staff is nothing new to the energy business. However, the way that vendors as well as subcontractors and operational staff connect to these systems have since changed. You would have heard from our colleague yesterday that with the convergence of IT type technologies in the operational or engineering type of processes domain, we're now seeing an increased set of vulnerabilities that previously were not designed for, or operators were not aware of. So enough about my journey. Let's start with yours. Today, we're going to spend some time looking at the OT threat landscape in energy and what could go wrong. We'll look at an overview of governance frameworks, which I'm aware that you have been exposed to yesterday in your lecture on OT, as well as a case study. We'll discuss some of our lessons learned, but I will invite you at that point to open up a discussion and use some of the information that you've currently learned throughout your learning journey and apply your mind to what these energy utilities could have done differently to secure their energy systems. So let's take a look at what does operational technology in energy look like. We have a diverse mix of energy in SA. According to the SA Department of Minerals, Resources and Energy, our energy mix consists of 6 resources. We're looking at natural gas, renewable and alternative fuels, coal, petroleum, nuclear, and as well as electricity. Examples of OT systems in this space include supervisory control and data acquisition systems, which commonly known as SCADA, control and instrumentation equipment, transformers that traditionally was operated with something called an electromechanical relay, as well as switches, gas processing plants, turbines and generators. So these are large machines that are used to actually carry out engineering processes, nuclear reactors, fire protection and safety systems, to name a few. To share a little bit about the nature of the OT environment, and I think this is something that we all must contextualize as we move to securing the environment, is that because of the nature of the assets and the large investment in the infrastructure, the cost to improve impacts profits. To plant downtime is required to implement changes because of the safety requirement that is, need to be considered as part of the change management process, thereby impacting revenue. So, if you speak to any plant manager or engineer, the number one task that they have at the beginning of every day is to make sure that the plant that they are overseeing is operational and safe to operate. New solutions means risk is of it not working once commissioned can lead to safety and revenue impact as well. So I think, again, looking at it at a broader sense, we need to understand that, while, for example, in environments such as business support systems and in the IT domain, there's a lot of security controls that are actually designed in those systems, as well as the way they are operated and maintained. Change management when it comes to embedding patching, for example, is a lot easier to implement with less consequence to safety as compared to the OT domain. There's also, because of the nature of the system and the complexity of the infrastructure, there's little oversight of the upstream and downstream impact of commissioning a new system into an OT system. Due to the complex nature of the environment, it could be difficult to find faults during commissioning, which again could impact safety and revenue. Just to share a little story, while I worked in the substation domain, I remember IT practitioners would come to me and ask me, but Michelle, why do engineers keep doing it the old way? That's an ancient way of doing it, they would say. And I would often say to them, it's because of the philosophy of thinking. After working in the field, what we found is that because of the nature of the environment and the direct impacts to revenue and safety, engineers are very reluctant to make changes to a system that is not necessary in their eyes. So there's a lot of change management and sort of awareness and education, but also working with system engineers to find out ways to commission new cybersecurity controls into the environment. So there's been quite a huge change when it comes to operational technology systems and their life cycle. Traditionally, when operational technology was introduced into industrial processes to improve safety and efficiency, these systems were usually built with proprietary, specialized hardware and software, as well as protocols. We had electromechanical switches, as you can see here by this panel, that was hardwired using copper cable. So if you can just imagine a copper cable going from a transformer to this panel, and that's how communication between infrastructure was actually enabled. This separation from traditional IT systems provided a level of security through something called air gap systems. And if you worked in the operational technology domain, you often hear that engineers would have designed these systems to not be internet facing and to have the network of their own isolated. However, as organizations seek to enhance operational efficiency and practices and introduce remote connectivity, OT systems are increasingly being designed with industry standard computers, operating systems, and network protocols. So that is the change that has occurred that has now introduced vulnerability to legacy systems, legacy systems that are now interconnected with these systems. This convergence with IT systems allows for improved integration with corporate business systems, but also exposes OT environments to cyber threats because these systems were built without cybersecurity in mind. They then become vulnerable to cyber threats. Example, many systems don't have basic protection in place like anti-malware or integration with tools that can respond to cyber threats. Also, integrating these cybersecurity tools to equipment that was not designed to work with these solutions or these systems introduces further downstream impact, like I mentioned just now. So a case that we might all be familiar with is the case that happened with CrowdStrike, where an untested update resulted in many systems in the operational technology domain being rebooted. And while this is not a cyber security incident, it is definitely an incident that had impact the security of a system, security, availability, and integrity of a system. Some of these OT systems resulted in large-scale confusion and in some cases provided or posed an unsafe operating condition, which then draws us our attention to the need to take supply chain risk seriously. So here we see an example of a converged energy system. We traditionally would call this we would call this substation automation. And across Africa, we are now taking the older technologies and we are phasing them out. And when upgrades are planned, we are building in substation automation. So as you will see here, there are very high, extra high voltage, as well as high voltage lines that are used to transport electricity via this equipment that you see here, which is a transformer. There's current transformers, as well as voltage transformers and power transformers. This equipment is managed and controlled by algorithms that are displayed via the human-machine interfaces. These little panels that you see here, it's called an HMI. So as you can imagine, to be able to do that, we use internet-based protocols, or what we traditionally known as IT-type equipment. So let's look at the threat landscape to energy systems, bearing all of this in mind. They face increased risk from a cyber adversary perspective, people who know that these systems are vulnerable because of the legacy component that they are connected to. They may exploit these connections because of this. The rise of wireless networking further complicates the security landscape as it allows potential attackers to access these systems remotely without needing direct physical access and of course bypassing all physical access controls. Because these systems are now connected to each other, protocols traditionally designed for IT systems are now introduced to OT environments. And these are typically malware, phishing attacks, zero-day exploits, and so on. Some threats that OT environments deal with include malicious insiders, where their intention could be sabotage, who are aware of vulnerabilities that exist in these environments, that wish to then sabotage the plant, or terrorist groups that equip and enable insiders to be able to conduct sabotage on their behalf so that they could get remote access, for example. The safety impact is large and is therefore these malicious actors use these system vulnerabilities, and not just from a technology perspective, but as a process and structure perspective, to gain advantage over their over the persons that they are trying to manipulate. While traditional IT security solutions work in most cases, they have not been developed with the OT environment in mind. Taking things into consideration like commissioning and ensuring that systems work well together is something that is usually not tested when it comes to an IT environment. The unique characteristics of these OT systems, such as real-time operational requirements, emphasizes the critical nature of their functions, and therefore solutions that are required to enable the environment, they've become tricky, because now you've got to make sure that every single control that you put into this environment is tested before actually commissioned into the system. So some incident scenarios, in terms of what could go wrong: interruptions or delays in the flow of information, and take a minute to actually internalize what that could mean. Let's take an example. If we, for example, had that breaker that I showed you earlier in the diagram, if a signal to the breaker was intercepted and that breaker did not operate and open when it needed to open, that could cause an overcurrent on that line, which means that it could have an unsafe condition. The environment could be at risk, but also the people that work on the plant would then be at risk. Unauthorized changes to commands, like I've just demonstrated in that example. Interference with equipment safety systems. So this is, not something that we've seen yet or know of. It may have happened, but because of the lack of visibility in these environments, we may not have heard of an incident. But interference with equipment safety systems is one of the most vulnerable ways for an adversary to actually exploit an OT environment, because it creates a lot of uncertainty and a safety risk. So how do we tackle this? I mean, it's so many different systems. It's large and complex in nature. What can we leverage to actually make a difference in this space? And the one thing that the cybersecurity community has emphasized is to take a governance program approach to this. To quote the Guide to OT Security, the NIST guideline, an effective OT cybersecurity program should apply a defense in depth strategy, while calls for layering security mechanisms such that the impact of a failure in any one mechanism is minimized, reducing the systemic impact of incidents. And again, here I want to highlight the need to reduce the systemic impact. And because of the nature of the environment and the risk to safety, there is no tolerance for an unsafe incident. Therefore, OT cybersecurity programs should always be part of a broader safety and reliability program in an industrial environment or in an energy plant. Threats to OT systems can come from numerous sources, including hostile governments, terrorist groups, disgruntled employees, malicious intruders, natural disasters, malicious actions by insiders, and unintentional actions by people who are just doing their job. OT security objectives typically prioritize integrity, availability, and safety, followed by confidentiality, but also must consider safety as an overarching priority. So according to the guideline, and from my own experience, one way to tackle this is to look at it from a defense in-depth approach. And security professionals will always say to you, at the end of the day, it's not a matter of when it will happen, it's a matter of it will happen. And we design with that in mind, which means that at every stage, every control that we put in place, and a control is something that should either prevent or detect malicious action. Every control we put in place must be designed to slow down the adversary so that the organization, the asset owner, can then take action to safeguard the assets and the safety of the environment within which it resides. So according to the guideline, a strong defense in-depth approach in OT includes multiple layers of protection, as you can see here from a fishbone diagram, very famous diagram in engineering process when it comes to root cause analysis. Given the nature of the environment for the strategy to work, there has to be a holistic nature. So controls need to work with each other. Applied using and across the people and organization, as well as technology and the processes for which you are actually securing. Next, we move on to an overview of governance frameworks. Aspects that form governance, and just to also quote what governance refers to from the Certified Information Security Manager textbook. Governance is fundamentally a process by which a company and its leadership exert strategic control over business functions through policies, objectives, delegation of authority, and monitoring. And I think it's very key for us to really pay attention to delegation of authority and monitoring. What usually happens in the industrial space is we tend to focus a lot on the technology layer of controls. And what we then lack is bringing the people as well as the processes of the organization on the journey. And that's actually where controls fail. And while you have spent a lot of cash on building technology controls, you would have these other elements that are not taken care of, then become your vulnerability in your organization and of your plant. So the first one we're going to talk about today is strategic direction. And these are elements of governance. It involves setting the overall direction for the organization and its various functions, including cybersecurity. Then we look at policy and standards. It's a core component of governance, and it's the development and enforcement of policies that matter, as well as the standards and procedures that then support the policies and the requirements to guide the organizational behavior. So if you're a person working in a plant environment, you would know that there's something called operating procedures. An operating procedure should then be changed, adopted, and adapted, to include cybersecurity controls and behavior so that the plant is then secure from a people perspective. Responsibility and accountability is a huge aspect because governance requires for roles to be established and for responsibilities to be delegated to certain individuals who has the relevant authority and skills and expertise to execute on the relevant tasks to keep the plant secure. Monitoring allows for us to look at, are the controls that we have in place actually effective? Are they doing what they're supposed to be doing to secure the plant? And we do this by looking at metrics and monitoring what is going on from a security controls perspective. Alignment is something that is often overlooked when it comes to governance and the importance of stakeholder engagement. In something of this nature, where the system that is designed is so complex and in some cases ancient, when I talk ancient, there are some systems in energy systems that are 60, 70 years old, which means that the operational procedures that were designed for these systems did not take cybersecurity in context. Without actually bringing people on board and sharing what the new version of the operating procedure could look like, you actually risk the operator introducing vulnerabilities into the system. Resource management, as well as organizational culture, huge part of the journey. as they say, if no budget is secured to actually put controls in place, it's likely not to take place. Okay, so what are some of the areas and frameworks that we use in energy and have used so far? So I've highlighted 4 areas or 2 standards and 2 frameworks that I've used in my experience, but also that has been adopted globally. It's the energy sector capability, cybersecurity capability maturity model. So that's the ESC2M2, which offers, which offers, and its purpose is to evaluate and improve cybersecurity capabilities in the energy sector. And by that, they specifically mean cutting across people, process, and technology. So not just the technology element. Some of the benefits that we derive from that is after using the maturity assessment tool, we can then provide and develop a roadmap based on the organization's maturity level and practices and encourage continuous improvement. So this particular model is developed specifically for energy and takes into context the constraints that energy and electricity sector actually has. The IEC 27019 standard focuses on cybersecurity measures specifically for energy utilities. Some of its key features include a risk management framework that's specific to energy utilities. The security controls are also applied for an energy environment, which is something that we often struggle with because a role-based access control, for example, is very different in an OT environment compared to an IT environment. The realm of control that you have in terms of flexibility is a lot less in an OT environment. The IEC 62443, which is an industrial cybersecurity for standard, and that's used broadly, not specifically designed for energy, but it can be applied specifically around new systems that are built for the OT environment. So there's a lot of emphasis on secure software design and how we ensure that original equipment manufacturers, but also OT system design and engineers of systems embed cybersecurity as part of the system lifecycle. The NIST CSF, now in version 2.0, is also a resource that we use to plot cybersecurity controls and the gaps in the energy sector. It's very useful because it is broad enough to cover the entire landscape and has now been adapted and adjusted to include a lot more aspects on governance as well. So we're starting to see that it's becoming very useful for an overarching program development perspective. Okay, so let's take a look at a few case studies. Let's go to the first one. We're looking at S-Power's cyber incident. So S-Power is a US-based renewable energy provider, and they were victim of a cyber attack that disconnected the grid operator from its power generating plant. They became the target of the first cyber incident that caused a United States power grid operator to lose connection to its power generation. And this is according to news websites. Attackers exploited an unpatched firewall that was meant to protect the power grid, microgrid systems specifically. This exploitation led to a series of reboots over a 12-hour period. So if you know, just to contextualize, depending on the nature of the environment and what commands and controls are actually coming from the grid operator, this creates additional other issues if those controls cannot be sent to the power plant. And I think, you know, in the case of safety and a resilient energy plant, there will always be the opportunity to move to manual switch over. But, you know, you can then actually see in the period to actually get to site and then enable the manual switch over, there's a lot of safety concerns that may arise in that process. So ultimately, the incident resulted in a denial of service attack, which flooded the system with busy work, which means that the command and control signals that may have been needed from the SCADA system may not have reached the primary plant, which, you know, your wind turbines, your solar plant, making it unavailable for its actual tasks as the firewall continuously rebooted. So as a consequence, S-Power lost control and visibility into their systems. While they had not needed to disconnect customers, this showed them how important it is to actually build cybersecurity controls and specifically firewall management into their operational processes. The other very common case study, and it's actually one that inspired my journey with cybersecurity, is the Ukrainian power grid attack. So in 2015, there was a phishing attack that was launched on the distribution company, and the attackers used targeted attacks to compromise the utility aimed at the plant operators. The emails contained malicious Microsoft files that deployed malware, allowing the attackers to steal operators' credentials. And I think, again, the threats that exist in the IT domain filter into the OT domain because we have operators, controls, engineering personnel that use both these systems. They then were able to gain access to the SCADA system and remotely controlled circuit breakers and cut over 230,000 customers for several hours. And I think there it really showed us how challenging it could be to play place in that scenario if your operators don't know how to actually respond to such an event. Just to let you know, in the world of control and automation in a power plant perspective, there's rigorous training and there's many procedures that each of the operators have to be trained on so that they can seamlessly execute an operating procedures. And if this is not part of that, it becomes a huge challenge for the shift manager, for example, to manage because of the uncertainty that it creates when it comes to safety.
Michelle, you've got 10 minutes left.
Okay, thank you so much. And with that, I come to the end of my discussion today, and I think, or shall I say my presentation, and I'm now opening up the floor to discussion. After listening to what you have in the past couple of weeks and also to my presentation today, what could S-Power and the Ukrainian power utility have done differently to avoid being victim to such an attack? And I'm hoping to hear from you.
Thank you, Michelle. Excellent, excellent lecture. The students are showing you a lot of love. We've got 402 of them in the room, so a big audience today. So what I'm going to suggest is I'm going to start with the hands up. So again, I'll ask students with their hands up, please only ask one question. Don't ask two or three in your turn so that we can get to as many people as possible. That's the first thing. For those of you who want to rather type something in the chat, for example, also answer the question Michelle just asked you in terms of what could S-Power and Ukrainian power utility have done differently to avoid being victims to this attack. Go ahead and type that in the Q&A if you've got a good answer there. In the meantime, I must inform you, and this is quite funny from a South African point of view, but the people in the Netherlands, our co-presenters, have been hit by a power outage during our talk on energy security. So I'm going to do this one on my own. I'm going to make Katleho Shekle a presenter with me. She's one of our Spanx ambassadors. So Katleho, you can just give me a hand when I need one, please. Also, by just keeping an eye on the chat for me, if you don't mind, Kat. You there, Kat? Okay, so I'm going to start by, cool, thank you. I'm going to start by allowing some mics so you can be ready for your turn. I'm going to go down in descending order. And we're going to start with Sibabalwe, Dianti. Sibabalwe, you can unmute and you can ask Michelle your question.
Can you hear me?
Yes, we can. Go ahead.
Thank you for a beautiful lecture. I just have one quick question is that how can organizations simulate OT cyber incidents without jeopardizing operational safety?
That's a great question, and actually no professor at UCT that is trying to do that. So look him up. His name is Daniel. Yeah, so we actually create environments. So we almost like create images of environments, and we move it to a lab space and simulate incidents there. It is evolving as digital twinning technology becomes better, and we are able to create an absolute replica of an environment. As these technologies and sort of interventions become available, it'll then become a lot easier to simulate these incidents and actually then prepare for them as well. Because right now we really rely on the engineering knowledge in the room within that organization to be able to simulate scenarios that then are built into security controls and forms part of a program.
Thank you, Michelle. Next question is a written one from Calvin Thompson. Safety is continually mentioned as a reason why you can't take the OT environment offline, but not patching the environment is a safety risk. Is this reasoning not self-defeating?
I love that. Absolutely is. So what we usually do to deal with this problem currently, and we're open to a lot more new suggestions and better ways of doing it, is that we do so during outages. So there's planned maintenance for these plant environments, which I'm starting to see is becoming more frequent. So we do all of that security activities and controls enablement during an outage.
Thank you, Michelle. Good answer. Katlego, your question? Kat?
I'm sorry, I don't have a question.
Oh, sorry, your hands up. Okay. I'm going to move on to Shungu Masawi. Shungu, you can unmute your mic.
Thank you so much. Thank you for a wonderful lecture. It was very informative. My question is just around the costs of ensuring the type of security you'd like to envisage in your industry, for example, and like the costs in terms of whether it serves as a deterrent against being proactive, or are we being proactive as it is? I'm talking in relation with South Africa. Where do we stand in terms of how proactive are we to avoid the situations such as, for example, the one Ukraine faced? How are we looking there?
I love your question. Thank you so much. And yes, costs are usually a huge hindrance. However, given the nature and the imperative of organizations to ensure a safe environment, we're starting to see operators allocate more budget towards this because they're starting to see, okay, there's a link between safety and security. Nuclear is far ahead in terms of this, given, of course, the safety impact should there be a security breach that leads to a safety incident. But the rest of the industries are slowly catching on, with the electricity industry actually being quite ahead in terms of making sure that suppliers are building it into their equipment as they deploy new systems.
Maxwell Matlow, let me just actually enable your mic. Allow mic. Maxwell, you can unmute, ask your question.
Thank you. Thank you for the insightful presentation, Michelle. So in the presentation, you mentioned that natural disasters are one of the factors that could pose a significant risk to OT systems. So I was wondering if you could give us an example and in a context format. Thank you.
Okay, flooding. Flooding is our biggest issue in South Africa right now. And you will find that a lot of systems, even though the environmental impact assessment was conducted, it was conducted 20, 30 years ago. So what we're starting to see is the change in environmental conditions is now introducing natural disasters as a security threat to the assets on the floor, on the ground, especially those that have not been planned for and designed with that sort of weather patterns and conditions in mind. So that's one example that we're currently going through in Southern Africa.
So another question from Anonymous. Let's hope it's not the Anonymous we all know. Amongst those 4 cybersecurity frameworks, which one is more preferred and why?
Okay, so there were 2 standards and 2 frameworks. I'll maybe speak from my personal journey with them. I have used all of them in some shape or form. And the reason for that is depending on the context of the environment that you're assessing and the risk landscape that you are facing, each of these frameworks and standards help you. So the ESC2M2 does have an aspect of NIST cybersecurity framework in it. So I would say if you had to start with the energy sector specific capability maturity model, and then look at the CSF to almost complement the ESC2M2.
That's interesting. Thank you for that, Michelle. Akidan Kehinde, Europe.
Good afternoon. My
Hi.
question is that what role does threat intelligence play in OT security?
Oh, that's a beautiful question. It plays a big role, and mostly because you can't design controls for threats you're not aware of. So the intelligence community is starting to see the importance of actually unpacking OT specific threats. So going in and understanding, what are the vulnerabilities in a programmable logic controller, for example? How can a traditional attack, a DDoS attack, affect a SCADA system? And that is some of the activities that the threat intelligence community is working, putting a lot of effort into so that we can design the right security controls for the environment in its context. So it plays a huge role, to answer your question.
Thank you, Michelle. We've got a whole list of Takunda Magugu. Takunda, you there?
Sure. Thanks. Am I audible?
Yes, you are.
Yeah. I just have a quick question to do with the line. We have been made aware to the fact that the line between IT and OT is being blurred. So with respect to that, I've come to realize that most of this OT technology is really, really old. And considering that in energy companies, we have a lot of restructuring here and there, CEOs may change, it might be partially owned, like in South Africa, partially owned government and private entity. How is it, what is the best way to incentivize, given this dynamic landscape that is ever changing, what is the best way to incentivize leadership to ensure that they have the right controls in place?
Well, the mission of the business. Let's keep the plant available and safe to operate. In my experience, that has worked for me, mostly because it's not about territory when it comes to securing a particular plant environment. Ultimately, we're all there to ensure that energy is produced, distributed, and transmitted, and that our customers get the vital resource that they need to actually grow the economy, but also sustain life. And when you look at it from that perspective, in my experience anyway, it's, there is no such thing as a line because we're all there to ensure the same. So an incentive would be to just get everybody in the room, all of the decision makers that need to actually take this risk seriously, and start to connect how they actually contribute to ensuring a safe and secure environment. And once you have that sort of stakeholder alignment and engagement, I was saying to you that that's the one part that always, is always missed. Then, there can be traction made when it comes to implementing these controls. The other thing is that executives need to be compacted. They need to have key performance measurements in their compacts and in their performance management to ensure that they're actually contributing to this versus hindering its success. So these are just 2 mechanisms that can be used to incentivize leaders of these businesses to take this risk seriously. I hope that answers you, Takunda.
Sure, thanks.
Michelle, I want to put something out there just also for the students, and this understanding that our current societies are actually run on what we call systems of systems. in terms of critical infrastructure, and that there's interdependencies in these infrastructures. So, for example, if you don't have energy, electricity, you can't pump water. So your water system also. So what I would like you to just explain to the students very briefly is what would happen in South Africa if the Eskom grid, for example, because Eskom is obviously a massive single point of failure. Also in cybersecurity terms, something you look at very, very closely. Where are your single points of failure? And because we don't have other electricity providers, we've got this massive one. What would South Africa look like if the Eskom grid went down in a cyber attack that was it downs the grid? What happens?
Well, don't quote me. What I can share is that the grid was designed with resilience in mind. Okay, which means the way it's segmented and the way it's designed, even though it was not designed with cyber risk in mind, it was designed for continuity. So while we might say, well, Eskom, if they faced an attack, that the grid is at risk, because of the nature of how it is designed and built, it's very, very unlikely that we would go out into a complete blackout because they have run the scenarios and they have built contingencies around it. What we also have in our mix now is that we have IPPs, whereas traditionally we just relied on generation from Eskom. That has completely changed the landscape for us in terms of reliability and the ability for the energy provider to produce and transport electricity to us.
There's good news, and I think there's the importance of resilience, which is perhaps something we haven't really talked about enough in this course. So Q&A. I'm going to go to Sholofelo Pitsanyani, who asks, in your own experience in the field, would you recommend that OT and IT be operated as two separate entities? And then Sholofelo says, I'm not sure that I'm making sense, but I think you are making sense.
I think it depends on the maturity of the organization, because there's a lot of cross-sectional skills that's required to manage this environment. From a perspective of making sure that each of the areas actually do what they're designed to do, what they're trained to do. So there is some motivation to bring the skills together. The only challenge that leaders then face with that model is prioritization, as well as then being able to literally just get the teams to work together. There's a huge culture difference. So I would say if you're designing a new organization, why not go for it and actually see how that works? If you're trying to embed OT cybersecurity in an older organization, I would say look at what is the maturity of the organization when it comes to its processes, how they link to each other, as well as the skill sets of the practitioners on the ground. Because the utility of the future, or the energy system of the future, is definitely going to need both these skills.
Thank you, Michelle. Brian Garber, you're up. You can unmute your mic.
Thank you. Good afternoon.
Afternoon, Brian.
Hi.
Thank you, Michelle, for the insightful presentation.
Sure.
My question, I think, has been answered slightly. What I was going to ask was, in terms of looking futuristically, are we going to see a migration from OT to IT systems, considering that a lot of the systems that are there are quite antiquated, and what are the new systems that are going to be introduced in the future? That's my question.
Okay. So I wouldn't call it a migration to IT fully, because there's still a lot of electromechanical processes that these systems do. What is introduced to, for example, a synchronous machine, which is like a generator, is the condition monitoring aspect. So that is something that usually an IT technician will know a little bit more about than someone who understands the machine. So to say that it's moving to IT, no. I mean, physics is physics. These engineering processes are here to enable physical interaction with the world. And the machines are designed with that as well in mind. So I wouldn't say that it would move to IT. I would say there's going to be a merge of the fields where we would need both these skill sets and processes to manage it safely and securely.
To answer that, Michelle, are we for cybersecurity professionals? Are qualifications frameworks evolving quickly enough to actually deal with the fact that cybersecurity professionals need to understand not only cybersecurity and IT, but actually be competent across the different technology domains, whether it's the industrial IoT or OT, etc. Are we evolving quickly enough, given the interconnected nature of new smart systems? If we look at 4IR and 5IR.
From my
What's your
personal
take on that?
perspective, I would say no. I'd say that we really need to fast track that integration, mostly because it's happening right in front of us. And if we're graduating engineers, for example, without that synergy and appreciation for processes in the IT field and vice versa, then we kind of putting our practitioners at a disadvantage. Because when they go into the field and now have to use equipment that has already merged these ways, it's not like processes, these different processes. They are then at the back foot, because then it becomes a tug of war situation where, but this is what my training has taught me, and this is what my training has taught me. They are different, you see. So I think that we really, really have to move on that, because the world has changed. We're already embedding new systems. I mean, IPPs are being commissioned all across Africa. And they're being commissioned with newer technologies that are already integrated. The change is here. It's just a matter of ensuring now that our practitioners have that appreciation for both sides of the table.
Thank you, Michelle. I think that's a very interesting perspective for the students as well. Thunder, Europe. Chanda?
Thank you very much, Madam Michelle. Your brilliance knows no limit.
That's
My
kind of you to say.
question, how can governance frameworks address the risks posed by state-sponsored actors targeting energy infrastructure, given their advanced capabilities and the difficulty of attributing attacks?
Well, I think that's definitely a political scientist needs to answer that question, but I'll take a stab at it. The one thing that is a huge part of governance is to make sure that whatever you design to be in place has to be designed according to a specific threat model. So part of the risk management process is to look at, so what politically is happening in this country that will then may or may not affect the energy system that you are securing. And then for that to fall into and then be tracked and monitored by the governance process. You see, it's not enough to just implement a standard and say that you are secured if you haven't done the necessary threat modeling work to understand the larger macro context of where this energy system is placed. So to answer your question briefly, it's to look at ensuring that in the governance model that you implement, that you're now looking at what is the threat model that is behind your risk program, and does it then relate to the macro context of the country in which this energy system is in.
So that was a brilliant answer.
Thank you.
It actually really was. Martin Adams, do you still want to ask the question? Marvin just gone. Perhaps we're running over. Well, Michelle, this actually got one more question in the chat, which I'm going to, not the chat, the Q&A. And the question is, do you think the line between OT and IT cybersecurity will continue to blur in the future? If so, what challenges and opportunities do you foresee as these environments become more blended and integrated?
Oh, definitely. I mean, it's happening already. The opportunities that I see is the cross-sectional skills. I mean, I haven't met a single IT practitioner that has walked a plant with me and hasn't been fascinated by the infrastructure that they are contributing to. Likewise, putting an engineer to work with an IT practitioner and actually seeing what these internet-based protocols are doing, and what's possible is also quite fascinating. So I think the opportunity of cross-sectional learning is here. In terms of the challenges, I think it's going to be quite challenging and I'm going to be very candid here, to encourage people to leave their egos at the door, because I think that the most important thing is to stay true to the mission, which is you're here to make sure that the plant is safe and secure to operate, and that it doesn't matter what we learned before and what we think we know is right. It's all about what's going to work for this context and for that collaborative approach to be taken. So challenge and opportunity, but it's quite an exciting time to be in the space.
I love that. And I think, if everyone takes something away from today, something you said right at the end here, and this is also going forward to complete out your SANCS experience and make sure that you actually pass it all and that you're successful, is complete the mission and stay mission focused. That is it's a big thing. Stay true to the mission as a team as well. And I love that. Michelle, I had a fantastic time. I so enjoyed this lecture. It's the first time I've ever heard you lecture. I thought it was brilliant. I loved the way you did it. Let me ask you to answer your own question right at the end for the benefit of the students. What could ISPOW and Ukraine Powered Utility have done differently to avoid being victims in this attack?
Implement a governance model that actually worked.
Yeah, there we go.
What usually happens, we think governance is just policies, but actually monitoring and making sure that the controls work together is part of governance. Making sure that you're building control strategies that are relevant to your threat landscape is part of governance. So I think the important key takeaway here is it doesn't matter how much technology you put in place. If the controls don't work together, adversaries will be successful. And governance is almost like the framework that brings everything together.
Thank you. I think that's a brilliant pose, actually. Powerful, often overlooked. So the students are giving you a lot of applause. Thank you, students. Thank you for attending the lecture. Because of the power blowout in the Netherlands, there won't be a Mentimeter tonight. So everyone gets time off for good behavior, and you can be home early tonight. And only 2 more days of classes, and then we're done with this section of the course. So hang in there, make sure you hit your 70% of classes. We're on track here. We're on track. And then don't forget that the competition, to enroll for the competitions, sorry, Michelle, I'm just using this quick time, that you must do that by Thursday at lunchtime, because if you want to apply to be considered for the talent accelerator, you must pass the school, which you're all sitting in now, and you have to enter the competition and be part of a team. Okay. So just remember that. You can go check it on LinkedIn, and you should watch your emails. Just a reminder, go and select which competitions you're interested in tomorrow. Michelle Govender, you've been a fabulous speaker. Thank you for giving up your time late in the afternoon, going into the evening. And this was great. And thank you so much.
Thank you for having me.
Thanks,
it was such
everybody.
a pleasure. Take care.
Yeah, loved having you. Thank you. Cheers, everyone. Have a good evening.